We are going to do the fundamental theorem of calculus. So it's fundamental, it's really important. It has to do with antiderivatives. So the reason why I have this here, we'll get you a sheet that looks like that. What is the antiderivative of x to the n? We've done that one.
X to the n plus 1 over n minus 1.
X to the n plus 1. I don't even have enough room divided by n plus 1. You don't have it, but you can put it down on the back. But we'll get you this sheet. We're not going to do all of them right now, but you're going to run into some of them. What's the antiderivative of the sine function? Negative. How do you know? I'll just put plus c here for everything, so then it's covered. How do you know if it's right? Take the derivative. What's the antiderivative of cosine?
So negative secant squared?
No. Derivative of secant squared is 2 times the secant times the derivative of the secant. Well, it's not simple, is it? Sine.
What'd you do?
It always says this because of the iPad. I don't know why.
Tree write it.
Oopsie. If you want to, we'll give you a sheet like this so you can write it down, sometime. These are what you have to know. Everything when you do antiderivatives have to look like this. Tangent and cotangent, that one's tough to do. That one's not obvious. What is secant times the tangent? That's the derivative of what? Secant. They're all up on my wall. And once you have one, you have the other. You just have to maybe guess a little bit. How about the cosecant, cotangent? Cosecant, now if I take the derivative of the cosecant, because it's a cofunction, it will be negative, so I got to fix that. How about e to the x? Adam? No? It's e to the x. Now a to the x is a little trickier. You know you're going to get a to the x. Now remember when I took the derivative, it was times the natural log of a, so the antiderivative wouldn't be times the natural log of a, but it'd be what? What's the opposite of multiplying by the log of a? Dividing. You guys know this one? ln of x. Secant squared, that's the derivative of which one? Tangent. And everything has to be one of these. Before, when you had derivatives, you could just take it and do it. We're going to have to manipulate some of these things. Not yet. But so they look like this. Cosecant squared is... If secant squared is tangent, cosecant squared is cotangent. Right. And it's negative. Anybody know secant, tangent? I've already done that one. I got it twice. Sorry. What about the next one? Does anybody remember that one? Sorry, I'll slide it. Inverse sine. You'll see that one on the exam, but even more so, you'll see the next one. That one you see a lot, inverse tangent. Yes. There they all are.
We had a quiz or something going up this week? What is it?
I'll get there. So what's our schedule? Might as well put it right here. Okay, so Tuesday, we're going to do 5.4 day 1. It's not bad. It requires a calculator. It just gets on what we do today, a little bit of review, and we're going to have a quiz. And it's going to be a few, I think there's like 3 multiple choice questions, but you have to explain them, and a free response. These are all AP. Remember, we're going to do the AP grading. Nope, then it's not bad. No, it's not that bad. Wednesday, we're going to do 5.4 day 2, which is the second fundamental theorem of calculus. It's very, very important. And don't make it hard, because it really isn't hard. But a lot of you make it hard. And that one's really important. There's a guarantee. Fundamental theorem 2, but both of them will be on the exam. Thursday, we have an antiderivative quiz, integral quiz. It'll cover what we did today and finding antiderivatives. So it's just integrals. It is not AP. It shouldn't take you the whole period either. Neither one. This one shouldn't either. And then Friday is a review day. And Monday is your test. Hate to do it to you on Mondays, but it's the way the schedule works.
We do it on Tuesday.
We're doing Tuesday and Monday. You don't want me to start chapter 6. At least I don't think so. Can't lose the day. I could switch the days. Uh-oh, that's a problem for me. I'm going to be going Wednesday. No, Mrs. Hersman likes to do it second.
Why does Mrs. Thurston?
She's got more kids, more stuff, more people to grade, so I'll talk to her, but it doesn't
She
matter.
grades really fast. She always had it graded like the next hour.
I'm pretty fast. I think she's faster. Okay, that's the plan. So we got a couple quizzes. Tomorrow, these are short, not bad quizzes. And that shouldn't even be graded on an AP scale, but it will be. Okay? These are summative, those are formative. Just a little category. Ready? No. The only summative are the tests. And then we'll be done with chapter 5, and then we'll have 2 more chapters. We're done. That's pretty awesome. Okay, ready? Oh, there are the answers. Now what I'm doing is saving these when I'm done as a PDF file, putting them up as a PDF. So then nobody else has smartboard software to see it. Okay. Oh, let's do a little preview. Now remember that if I wanted the area under the curve, if this is time and this is velocity, and I say that the velocity you're traveling at a constant 60 miles per hour, and you travel for 3 hours, I would get a horizontal line, and I could find the area under this curve, right? So it's the integral from 0 to 3 of 60 miles per hour dt. You could actually do an antiderivative, or you can do geometry. Wouldn't you rather just do geometry? This is 60. How many miles have you gone? 60 miles in 1 hour. You can do it dimensionally. It really helps. Times 3 hours. How many miles have you gone? 180 miles. If you have a graph that looks like this, you could find this area graphically, right? It's 1/2, or geometric, I mean, base times height. So the question is, how do you find the area under, like, a quadratic? I can't do base times height. I could divide it up into some rectangles or trapezoids. I could get an approximation. I want to get the exact answer. Well, what turns out is to find this area is an exact answer. It's the antiderivative call of the function evaluated at this point and that point. And that's the fundamental theorem of calculus. Riemann said, let's slide this up here. He said, I'm going to find the area under my function curve, here's f of x, and I'm going to divide it into a bunch of rectangles. The biggest rectangle's base is going to go to 0. If the biggest one goes to 0, then all the other little ones also have to go to 0. And basically you're going to fill up this whole curve. That's what this is. That's called a Riemann sum, named after the German mathematician Riemann. Gołębowski sum. So if they ask for that, they're asking for you to find the area of a finite number of rectangles. You're not going to do an infinite number. We skip that part. And then Riemann says, you know what, I don't like to write all that. That's a lot of writing, and mathematicians are lazy. So he invented this. This is by definition. Correct. This is the area, you see the rectangles? This is the base, right? And that's the height. And he says, I want to make up my own symbol, so I don't have to write all that limit and stuff. That's what it means. So this symbol here means find the signed area under the curve from A to B. So if A is here and B is there, I want to find all that area. But then the amazing thing is, at least to me, I think it's amazing, Newton and Leibniz and Riemann, probably all about the same time, discovered after doing these and doing an infinite number of ones, they saw a pattern. And they said, you know what, that area under that curve is equal to the antiderivative evaluated at this endpoint and the antiderivative evaluated at that one, and we subtract it. It's subtraction commutative. It's order matter. Order matters. So if you think about it, if you switch the A and the B, just looking at this formula, that would make this reverse, because that's a minus sign. This is a theorem. Proving it is hard. If you want me to do that, I can make a little video and post it. It's a hard theorem, but it should bother you. Why is the area under the curve the antiderivative of the function? This is a silly little power rule or whatever we just did. Now, when we did derivatives, remember we took a curve and we took a point here, and then we took a point over here, and we dragged these points closer and closer together, and we took the limiting value. And when you looked at that formula for the definition of a derivative, remember it's the limit as h goes to 0 of f of c plus h minus f of c. Guess what? That's just the change in y over h. That's just the change in x. I see slope there. That makes sense to me. This follows. This does not follow. If somebody can tell me why they think it's an antiderivative, be my guest. I know why it is, but because I've done the theory. But you're not going to think about it. It should bother you. Well, I'll make the video and put it up online because the proof will take probably about 20 minutes to go through. It's pretty cool though, but it is the area under the curve. And when you add them all up, you end up with what they call a collapsing sum, and everything subtracts out except for these two things. And it turns out it's the antiderivative. Well, right now we're just going to believe it. Now, this is huge on the exam. Anytime they ask for total, they're going to give you a rate, like the snow is falling 6 inches per hour. What was that out in Denver? Did you see that on the news? How fast the snow was coming down? Well, they had like 16 inches of snow, someplace it was feet. So it was falling pretty fast. But, yeah, so, well, no, 4 feet. No, Alaska has 16 feet. Yeah, there are places in Alaska that fit so much, yeah.
They have like roads that will show the like paved, and they'll show these tiny cars driving through the roads. And they have like 25-foot walls of snow that are really following.
Oh.
Well, that was like the Halloween blizzard here. When we had the Halloween blizzard in 1991, you guys are too young. And my road, I lived out in the country, and they literally had to dig a tunnel out because the snow was that high. I think we had like 30 inches of snow or something. It was incredible. Yeah, and then we had snow Thanksgiving and no snow the rest of the year. You couldn't even drive. The roads were so bad, it took 3 weeks for the ice to get off the roads. You could only go like 20 miles per hour. It was miserable. Okay. So we can talk about the snowfall rate. And if the snow keeps falling at a constant rate, I can find the total amount of snow after so many hours. And that's what you're going to do. You're going to see that on the exam. It's going to be question 1 or 2. Well, it always has been. So you're going to see it on the exam. So how do we do this? This is easy. Look at this. This is the lesson. It's not a long lesson at all. So what we're going to do is find the antiderivative of this, and we can check it with our calculator. So what is the antiderivative of x squared? Now you remember that little symbol, that little s and a dx together means find the antiderivative of this. What is that? It's x to the third over 3. And now what we're going to do, what else is there? Plus c. We're going to evaluate that. That's how I write that, as 1 at 1 and 3. Okay, Adam, you guys back there, you need to be paying attention. So when I substitute 3 in there, I get 3 cubed over 3 plus that constant. And then I'm going to subtract, and I must have parentheses. Now I'm going to substitute 1 in there. So it's 1 cubed over 3 plus the constant. And then we're going to find a value. What is 3 cubed over 3? 9. So it's 9. What's going to happen with these? They're going to cancel. They always cancel out. So I don't need that. So it's 9 minus a third, which is 8 and 2/3. Well, we can check it on our calculator. By the way, when you get an integral that looks like this, when you have these limits here, it's called a definite integral because there's a definite answer. Remember, it's a signed area. You're still finding the area. If you have just this, it's called an indefinite integral. Now, how do you check your answers on your worksheet? You know if you did it right or wrong. No. Those were indefinite ones. Take the derivative of all your answers and see if it matches up. So we're going to graph this from 1 to 3. I don't know how Mrs. Hersman gets the FNINT, though. And I'm going to clear that out because we want to start all over. And this is x squared, so I like to put my function right in there just because I mess up parentheses. This one's pretty easy. I probably wouldn't. You could graph it if you'd like. You could use a Riemann sum program and make a whole bunch of rectangles. But we're going to use math. And it's going to be 9. Do you guys remember that? I'm going to go up. You know you can go up, right? Oh, there's the summation. Cool. And this would be FNINT, and this is going to be from 1. So if you don't have the new operating system, you should get it, to 3, and then this is Y1. I'll write out what it would look like. I said Mrs. Erdman can get it up here. I can't. And we have to tell what variable. So if you're in multivariable calculus, you could use your calculator. There it is. So what does it look like if you don't have the pretty print? It looks like FNINT. This is a syntax. You know, syntax is like grammar. It's Y1, I put it in Y1, comma X, because that's always going to be our variable from A to B.
So the Y1 just x squared.
Yes. We'll do one more, and then you're going to ask me questions, and we can have some work time, which was nice. Okay, what is the antiderivative of this one? First thing, what should I do with that 2? Let's play it out. It's in the way. Example 2. There should move as all up front. So it's 2 times. Pardon? This, no, this is positive. Because does it matter? Does order make a difference? Yes. You have to have this one first minus that one. So it's going to go from 1 to 3. She probably went 3 to 1. And so that should make sense now if you integrate from A to B, and I said that's the same as minus B to A. It also matches with my fundamental theorem. I'm switching the, which ones will be subtracted from which ones. Okay, so now let's go ahead and do this. And all this symbol means is find the antiderivative of the sine function. What is that? That's right, negative cosine of t, and I'm going to evaluate it at pi over 6 and pi over 2. Now, they get you on the multiple choice. You have to know how to do that on the multiple choice. On the free response, all I have to do is substitute those values in, and I'm done. It's kind of interesting. Now, be careful with the signs here. It's minus 2 times the cosine of, which one's going to go first? Pi over 2. Minus, don't get that minus sign confused with that negative sign, negative 2 cosine of pi over 6. Well, that's right. Do I need the c's? No, they're going to cancel out. Do you know what the cosine of pi over 2 is? Here's 0, here's 2 pi, here's pi, and these are halfway, there's pi over 2. So it's 0, isn't it? I'll write that down. That's 0. What's going to happen when I get the 2 negatives? Plus 2 cosine of pi over 6. And now I forgot my triangles. What's pi over 6? How many degrees? 30, right? I didn't even write that down. This side is 2. This side's 1. That's square root of 3. So what's the cosine of pi over 6? Square root of 3 over 2. So it's 2 times the square root of 3 over 2. And to match it, if it's in the matching, you'd have to simplify that. If we were on free response, this would be good enough. Do not have to evaluate that. Kind of nice. Pardon?
No. If we simplify, we get anything extra.
No, if you simplify one, you get the points taken back. But it'll be on the multiple choice part. So I don't know if you want to try a homework problem together. We are on day 3. And really, after we get through this stuff, we're just going to be all
We're just going to be cruising.
applications. Yeah, we'll be done before spring break.
Are you going to give us homework over spring break?
Nope.
Okay. I'm going to be in different country.
Let's do 27, because that's a little harder. Oh, let's do a new page.
I'm just going to come back, sir.
And I think the book does this really in 5-4. But we bring it in sooner because it doesn't make sense not to. I don't know. Yeah, they call it this fundamental thermocalculus part 2. It's on page 299. But honestly, they do that.
Is our assignment what's on our...
It's on your assignment sheet. On the assignment sheet, I hope it is the same. I don't know.
So it's day 5?
I don't know. It's the third day in 5-3. Wait. Right here. Day 9.
Day 9.
So we're on day 9. If you want a reference for this, it's page 299. It's ahead of where we are, but that's okay because they just kind of wanted you to guess on it. Just didn't make sense to us. We couldn't figure out how to do the problems if we didn't know this. What's the antiderivative of 1 over 1 plus x squared? Inverse tangent. And you're going to evaluate this at -1 and 1. Now, I have a hard time with these inverse trig functions. So I like to rewrite them. Minus inverse tangent of -1. Ready? You guys, Adam?
Shut up.
How do you find that? I need you to focus here. Here's what I do. I take inverse tangent of 1, because I can't even think that way. Because what is an inverse function? It's a what? It's an angle. So I call it theta. So this means, I always rewrite it, the tangent of what angle gives you 1. It's a lot easier. I see that a lot better. No. The tangent of what angle gives you 1? Can't be 0. Draw a triangle, the tangent of what angle? To get 1, these have to be the same. So what's theta? No, 45. Pi over 4. Okay? How about the next one? So I picked a hard one. The first one's not good. The inverse tangent of -1 equals theta, which means, I'm going to slide that up,
Which means...
the tangent of theta is equal to -1. And when I do my inverse trig functions, I forget about the negative, and I find the reference angle. It's pi over 4. Do you remember where the tangent can only be in what quadrants? If you put it in your calculator. Here's pi over 4. First and, no, fourth. And this is minus pi over 4, so that's what that is. So this angle here is minus pi over 4. So it's really pi over 4 plus pi over 4. How much does that add up to? Cool? 2 pi over 4 or pi over 2. Yeah, that's all there is. So you're doing exactly what you did before. You're just now going to evaluate your function, your antiderivative, at those limits. They're not limits in the sense of limits and derivatives, but they're called limits. Were there any ones out of the worksheet that you had trouble with? don't even know if I have a worksheet. How do you know if they're right or wrong? Just take the derivative. Mm-hmm. I don't think the calculus is more of as much of a problem as finding out what that angle is.
I think it's the trig.
I personally think it's all
Okay, so you should have books out, and you might even be able to get this assignment done. And it's actually nice day out there. Sun is finally shining and everything. Call. I didn't put you in a very good place, did I? Oh, yeah. Do you have questions on your homework? You want this time to work? Hey, work for me. I don't want that.
I know.